Okay, now let's talk about finding a line that is tangent to the curve. Okay, remember, secant hits the line in 2 points. A tangent only hits our curve in one single point, so it just grazes the edge. Okay, we want to start talking about how to find tangents to curves. Now, this is kind of tricky, okay, because the way we define slope is between 2 points. Everything we've ever done has involved finding slope between 2 points. Now what I'm going to ask you to do is find the slope of 1 point. How do we do that? That doesn't really seem to make much sense, right? Let's take a look. Okay. What we are going to do, okay, is take 1 point and then take a point that's a distance of h away. Okay. Then I'm going to investigate the limit as h approaches 0. So as that distance between these 2 points goes to 0. Right? So visually, let's take a look at what that means. Okay? So here, I want to find a point, or find the slope of this point, okay, the instantaneous rate of change of my blue curve. Well, to do that, I'm going to start with this secant idea. Okay? I want to find the slope between 2 points. So I'm going to pick a point A. Well, that would be the point A, f of A. Right? Its y value would be f of A. Then I'm going to pick some other point and a distance of h away from A. Right? So I'm going to just call that x value A plus h. And I'm saying that I'm starting at A and going a distance of h. So now I'll be at A plus h. Okay? Well, then the y value at that point would be f of A plus h. Okay? So I've got 2 points. I've got A, f of A, and A plus h, f of A plus h. Well, let's find the slope between them. Okay? So I know that slope is f of b minus f of a over b minus a. Okay, so if I plug all of this information in, okay, I'm going to have f of a plus h minus f of a, those are my 2 y values, over b minus a. Okay, my b value is a plus h, and then my a value is a. Okay, so plugging all that information into my slope formula, or into my average rate of change, I get this. Okay, then we can simplify the bottom a little bit. Right? And I can say that this is just f of a plus h minus f of a over h. Okay, so this is what we did. Okay, we just said, well, the distance that I've traveled, okay, the difference in the y's, is f of a plus h minus f of a. Okay, that's this change in y over the change in x. The distance between a and a plus h is just h. Okay, so that's what we found here. Now, we want to use this to talk about the instantaneous rate of change, okay, the slope at this point. The way I'm going to do that, okay, is with a limit. I'm going to say, as h, as this distance gets smaller and smaller and smaller, as it goes to 0, what happens? Okay, as that distance goes to 0, I can find this slope right here. I can find the slope of a line that is tangent to the curve. Okay, it's the line that just hits the curve in one single point. Okay? So, this is the key on the next slide here. I am going to define the instantaneous rate of change, okay, the slope at a single point, like this. The limit as h approaches 0 of f of a plus h minus f of a all over h. Right? It looks kind of ugly right now, but let's take a look at an example here of how we can use this to find instantaneous rate of change.